VOGEL'S approximation method. VOGEL'S approximation method is used to find the initial basic feasible solution for a transportation problem. So let us consider a problem. Find initial basic solution by VOGEL'S approximation method. The transportation problem is given here. So here this is the supply and this is the demand, and source O1, O2, O3, and destination D1, D2, D3, D4. Now, in Vogel's approximation method, first we will find the row difference and column difference For the row difference, what we will take is consider the first row and find the first two least elements. Here, 2, 1, and 3, and we will find their difference, that is 2. Similarly, for the second row, the least element is 2 and second least element is 5. The difference is 3. And here, least element is 2 and 3. The difference is 1. Similarly, for the column, here 3, 2, 8. So 3 and 2, their difference is 1. Similarly, here 1 and 3, their difference is 2. 5 and 3, the difference is 2, and 2 and 4, the difference is 2. Now, consider the check which which is the highest. Here 1, 2, 2, 2, 1, 3, 2. So this is 3 is the highest one, and it's represent the second row difference. So in the second row, we will take the least element. Here the least element is 2. Now we will fix this cell and check the demand. Demand is 250 and supply is 400. So the least one is demand. 250 I am taking here, and I am subtracting this from here, and 250 from here, that is 150. Now here it becomes 0. So I am cancel out these. Now after that, again we will find the row difference. So in this row 1, 7, 4. So the least element is 1 and 4. The difference is 3. Here 5 and 6, the difference is 1. 5 is 6, the difference is 1. And 3 and 2, the difference is again 1. So this is, and here the row difference is column difference is 1 and 3, 2, 5 and 3, 2, 2, 4 and 2, 2. And the greatest element is 3. Now this is the greatest element 3. So I will consider. Now this is in the first row. So the least element in the first row is 1. And we will fix this cell. And here demand is 350. Supply is 300. So I am taking supply 300. And subtracting 300 from here, you will get 0. Here you will get 50. Now this row get cancelled. Now again, so this row, first row and first column get cancelled, and now we will again find the row difference. Here 5 and 6 is there. So first row is already crossed out. It's 1, 3 and 2, 1, and this row is cancelled out. And 6 and 3, 3, 5 and 3, 2, 9 and 7. So the 7 is the greatest number. So now we will fix this column. The least element is 2. Now in this 2, we will fix this cell. 200 is the least. 200, this becomes 0. This is 300. 200, 300. So what we will do is we will cut out this, and we will get so the first row, first column, last column is taken. Now again we will find the row difference. Here 6 and 5, 1, 3 and 3, 0, again, 6 and 3, 3, 2, and this. So the greatest element is here, 3. Now, in this column, the lowest number is 3. So we will fix this. And here there is 50. 50 I am taking 0. And here 3 and 250. So 250 is there. And what we will do is, we will cut out this. So we cut out that. Now, what we will do is, now we will again find the difference, all differences. So in this, here the column difference is 5 and 3, 2. 5 and 3, 2. Three, 2. And what we will do is, in this there is no other cell. So here it is 250 is minimum. I'm cancelling 250. So I will get 150. And this is 0. And this will get. Now what we have is here 150. I will put 150 here. So this becomes 0 and this becomes 0. So 150 is there. So we cancel out everything and we got 0 demand and 0 supply. Now what we will do is, we will find the basic feasible solution. So that is, we will find all occupied cells. So that is 300 into 1 plus 250 into 2 plus 50 into 3 plus 250 into 3 plus 200 into 2 plus 150 into 5. The total amount is 2850.